Okay, we are ready now, so let's get started. Today we'll be working on average rate of change and increasing and decreasing function. You can see we are working on two different concepts today, okay? So we have two big objectives today. One is to explore or understand the rate of change, the average rate of change. And the second one is understanding the increasing and decreasing function. Increasing and decreasing function. So we're looking at two big concepts today, okay? So let's start with the average rate of change, which involves a little bit of mathematics. So let's begin there. First, we want to define the average rate of change. So as I'm explaining the thing here, make sure you copy the thing in your notebook for future reference. The average rate of change, sometimes we write it as ARC, average rate of change, okay? Average rate of change between two input values, x1 and x2, is the total change of function value. See, that is how we define. It is the total change of function value divided by the change in input value. So it is the total, I'm going to underline that part, total change of function value or output values divided by the change in input values. So let's try to understand the meaning of this one with the help of this diagram. So in this diagram here, I have shown a function in red. Let's say that is y equal to f of x. Okay, y equal to f of x or f of x equal to y, it is the same thing. So we have this function. Now what we are doing is we want to take two input values. Between two input values x1 and x2, we are measuring the average rate of change between two input values x1 and x2. So we are going to take those two input values. So the first input value is here on the x-axis where I'm pointing, okay? That is x1. That value is x1. And the input value over here, say for example, that is x2. So we have two input values, x1 and x2. Now, if you look at, these are the input values because these are the values along the x-axis, as you can see. Okay, these are the values along the x-axis. Now, if you want to look at the corresponding function value, if you remember from previous class, to find the function value, we go up to the function, we put a dot on the function like that, and then we look for the corresponding y value. Now, if you want to look at the corresponding y value there, the y value is the value on the y-axis. So this is the value on the y-axis where I'm pointing, okay? And that value is the value of the function at x1. So the value of the function at x1, we write f of x1. Okay, that is the value of the function at x1. Similarly, if you want to find the value of the function at x2, then you'll go all the way up to the function, put a dot there, here, right? And you look for the corresponding y value. So if you want to look for the y value, you will see the y value now. You will go towards the y-axis from there. Let me try to draw the horizontal line traveling to y-axis. So that is the y value. Okay, this is our y value. So this y value is the value of the function at x2. So we write this as f of x2. So this is f of x2. So one more time, if you look at the screen carefully, you'll see that when we have x1 here, the value of the function is f of x1, which is here on y-axis. Similarly, here we have x2, which is the input value. The output value or the value of the function is on the y-axis, that is f of x2. Okay, we can also use these two values to write this point here and this point. If I want to write that point, if I want to label this point A on the graph, if I want to label this point A on the graph, you know that the point is x comma y. Here, x is x1, y is f of x1. So this point will be x1 comma f of x1. f1 comma f of x1. That is that point. Similarly, if you want to find this point here, or if you want to label that point, let's call it point B, that point is also x comma y. For this point, the x value is x2, and y value is f of x2. It is f of x2. So we have labeled everything. Now, if we want to find the average rate of change, look here, average rate of change, that's our goal here, average rate of change. And if you look at the definition, average rate of change between these two values, x1 and x2, means equal to total change in function value. When we say total change in function value, the initial function value is here at f of x1. The function has increased to f of x2. So the change will be f of x2 minus f of x1. Change will be f of x2 minus f of x1. Okay. Total change in the function value, that is the output values, the values along the y-axis, divided by, so we have to divide this change, we have to divide everything, okay, divided by change in input values. So if you look at the input values, these are the values along the x-axis. Initial input value was x1, now it is increased to x2. So the change will be x2 minus x1. Change will be x2 minus x1. So this one, the equation that we got here, this is the formula to find the average rate of change. So make sure you highlight that as a formula. So I'm going to put it inside a box here, like this. So you'll also highlight it in your notebook. So this is the formula. So this is the formula to find the average rate of change. Now, let's see what it will give besides the average rate of change. Let's find out what we can get from this formula. If you look at this graph carefully, you can see point A is x1 comma f of x1. So x coordinate is x1, y coordinate is f of x1. Similarly, at point B, x coordinate is x2 and y coordinate is f of x2. And if we write like this, you can see we have f of x2 minus f of x1. That is this y value minus this y value. That means your numerator is change in y. Similarly, if you look at the denominator x2 minus x1, that is the difference in the x coordinate. So what we are measuring here is change in y values over change in x values. Meaning of that is this one, numerator is going from here to here, that is the rise. And then denominator is x2 minus x1, that is the run. Okay, so average rate of change is similar to rise over run. That means it will give you the slope. Slope of what? Slope of this line here in blue. Slope of this line. This line is called the secant line. Secant line. Secant line is a line that crosses the graph in 2 points. See this rate graph, the secant line intersects the rate graph in 2 points. So what we can say is average rate of change gives the slope of the secant line passing through these 2 points, point A and point B. So we can add that comment there. So ARC, or average rate of change, gives the slope of secant line passing through x1 comma f of x1 and x2 comma f of x2. So that's why the formula looks very similar to the slope formula. So what we have done so far is we look at the formula for the average rate of change, and also we look at one of the applications or one of the fundamental meaning of the average rate of change that gives the slope of the secant line. So finish up this writing. If you have any question, you can send me question through chat. So I'm going to pause here a little bit and give you time to finish up that writing. Aditi, are we done writing? Yes, okay. Okay, then let's continue. So let's go to example here. Here is the question. Please copy this question. First, copy the question, and we are going to talk about it. Okay, let's see. Vidya, are we done copying it? No, not yet. Okay. 30 more seconds. Okay, let's check one more time. Samyo, give thumbs up if you are done copying it. Samyo, are we done copying it? Yes, okay.
Yes.
Okay, wonderful. Okay, now let's work on this. See, the question says compute the average rate of change, okay, or the slope of the secant line. That's the meaning of that. For this function, f of x equal to x squared minus 1 over x on the interval 2, 4. So see, we have the function. It's a function f of x equal to x squared minus 1 over x squared. That's our function. And also they have given the interval. We are calculating the average rate of change on this interval, 2, 4. That is from x1 up to x2, right? From x1 up to x2. Your x1 is a 2 and x2 is a 4, okay? In order to find the average rate of change, now we know the formula. So that's where we are going to begin. So what we know is, let's write this. We know average rate of change is f of x2 minus f of x1 over x2 minus x1. Just like the slope formula, right? Value of the function at x2 minus value of the function at x1 over x2 minus x1. So this is just like y2 minus y1 over x2 minus x1. It's just like the slope. But you know that your x1 is 2 and x2 is 4. So we want to find the values of f of x2 and f of x1. So we are going to do a little bit of side work there. So here in the side, we are going to find the value of f of x2 and f of x1. So what is f of x2? Let's find that. So if I want to find f of x2, everybody look at the screen. f of x2 is f of 4, right? x2 is 4. So that becomes f of 4. And you know that f of 4 means you have to plug in 4 into this function. Our function is, everybody look at the screen, our function is x squared minus 1 over x. X squared means 4 squared, which is 16, minus 1 over x, that is 1 over 4. So that becomes 16 minus 1/4 is 0.25. And 16 minus 0.25 is 15.75. That is 15.75. Okay, f of x2 is 15.75. Here in the formula, we need f of x2 and also we need f of x1. Let's find out f of x1. F of x1 is equal to f of x1. Here you can see x1 is a 2. So it is f of 2, which is equal to, if you plug in the value, it is x squared, that is 2 squared or 4, minus 1 over x. In this case, x is 2, so it is 1 over 2. So it becomes 4 minus 1 over 2 is 0.5. 4 minus half is 3.5. Right? 4 minus 0.5 is 3.5. So we got the values. Now what you have to do is you have to plug in these values into the function or into the formula to find the value of average rate of change. So here, if we plug in, see f of x2, we got here f of x2 is 15.75. 15.75 minus f of x1, you can see f of x1 is 3.5 divided by, in the denominator, we have x2 minus x1. x2 is 4, x1 is 2, so that is 4 minus 2, which is equal to 15.75 minus 3.5. If we subtract that, that is 12.25. You can also subtract that using calculator if you want. 15.75 minus 3.5 is 12.25. Divided by, in the denominator, you can see we have 4 minus 2. 4 minus 2 is a 2. And when you divide this, 12.25 divided by 2, that will be 6.125. So the average rate of change is 6.125. If you need help in dividing the decimals, you can definitely use your calculator. Okay. It is okay to use calculator here. If you have any question on this one, you can send me the question through chat or you can unmute yourself and ask. Okay. Otherwise, I'm going to give you a minute or so to finish up this writing. Okay, look like you are done copying it, but let me check. Chandana, are we done copying it? Okay, got a thumbs up. So we are done. Okay, let's move on to next example on finding the average rate of change. This time we have a question in the form of a graph. So first copy the question and also copy the sketch of this graph on your notebook. Probably you'll take 1 minute here. Maybe you need 1 minute here again. So please copy it. Vidya, are we done copying it? Not yet? Okay, okay. Okay, now I can see that many of you are not writing, meaning you are done, right? Okay, let's talk about it. So here, instead of giving the equation of the function, they have given the graph of the function here, okay? So that is our function y equal to f of x. If you want to label it on the graph, you can do that. That's y equal to f of x. And we are asked to find the average rate of change on the interval from -1 up to 2. So that means this is our interval from x1 to x2. Okay, so you can see your x1 is -1, x2 is 2. And to find the average rate of change, we know the formula, just like the previous one. We know average rate of change is f of x2 minus f of x1 over x2 minus x1. Now for this problem, you can see that your x1 is a -1. This is your x1 here. Okay, x1, let me point with the red color there. So that is your x1, right? And if you want to find the value of f of x1, then f of x1 will be, you go to the function there and then find the value on the y-axis. If you look at the value on the y-axis for that, you can see that the value of the function at -1 is a 1. So that is 1. So here we can write f of x1 is 1. Let me write somewhere here. F of x1 is f of -1, that is equal to 1. Right? F of x1 is f of -1, that is equal to 1. Similarly, let's find the value of the function at 2 on the other side. So 2 is here. Let me point out with the dot. This is 2. Now, if you go to the function, that point is the point corresponding to 2 on the function. And if you look at the y value for that, is 4. So we can say f of x2 is f of 2. Okay, f of x2, because x2 is a 2, and the value of the function at 2 is 4. So this is equal to 4. So we have the value of the function at x2, and also we have the value of the function at x1. Okay, this is the value of the function at x2. This is the value of the function at x1. So once we have this, what we can do is we can plug in the values into this formula to find the value of ARC, the average rate of change. So let's plug in. So f of x2, we got it here. F of x2 is 4. 4 minus f of x1, we got here. F of x1 is a 1. Divided by, in the denominator, we have x2. You can see x2 is a 2. And then minus x1. Look here, x1 is a -1. So make sure you write that negative. Don't forget that negative, like that. Okay, so if we write like that, your numerator is 4 minus 1, which is a 3, but denominator becomes 2. Then both negative numbers are there. So negative and negative makes positive. So it becomes 2 plus 1. So meaning of that is this becomes 3 divided by 2 plus 1 is also 3. And 3 over 3 is a 1. So the average rate of change is 1. Okay, that means if we draw a secant line, passing through these 2 points, this point and this point, then slope of that secant line is 1. That is the meaning of that. Okay, if I draw a secant line like that, then slope of that secant line will be 1. You can also check it. You can see if you want to rise here, if you want to go up, you can see 1, 2, 3, rise 3. And if you want to count the run, 1, 2, 3. That's why we got 3 over 3 here. Okay, if you want to measure the rise for this line, 3 units up. Run for this line, 3 units horizontal. That's why we got 3 over 3, which is a 1, because the average rate of change gives the slope of the secant line passing through these 2 points. Okay, and if you want to label those 2 points, you know that this first point over here, x is negative 1, y is positive 1. So negative 1 comma 1. Similarly, if you want to label this point here, you can see the x value is 2 and y value is 4. So that point is 2 comma 4. So that is a little bit more interpretation about the average rate of change that we have calculated here. But the question demands only the calculation of the average rate of change. Okay, but there is always more than calculation and getting answer to any math problem. So you can always try to look for some interpretation, some more information that you can get from the problem. Okay, if you have any question on this, you can ask me now. You can unmute yourself and ask, or you can send the question through chat. Okay, look like there is no question. So this is the first part of our chapter, okay, for today. That is the average rate of change. Now we are going to move on to the second part where we'll be talking about the increasing and decreasing function. So first, we are going to talk about the fundamental definition of increasing and decreasing function, and then we are going to look at the example. So what I want you to do is I'm going to give you a minute here, a minute and a half, to copy this thing, and then I'm going to explain it. So first, copy the definition of increasing and decreasing function. Okay, let's now talk about the definition and try to understand the increasing and decreasing function. So if you look at the definition, because it is written in more mathematical form, sometimes it is not easy to comprehend that. Let's see, a function f is increasing function on an open interval if f of b is greater than f of a for any two input values a and b in the given interval where b is greater than a. Okay. So when we just read that, it's not easy to follow through and understand the meaning easily. So what I'm going to do here is I'm going to explain you with the help of this graph. So if you look at this graph, let me draw a vertical line in the middle just to separate some values here like that. You can also draw if you want. Okay, so now you can see that I divided this entire x-axis into three intervals. The first interval is the interval where x is less than -2. Okay, make sure you look at the graph and try to understand. X is less than 2. The other one is between -2 and +2. And the last interval is from 2 up to infinity. Okay, from 2 up to infinity. Now, if you look at this interval, the first interval here from -infinity up to 2, in that interval, when you go from left to right, see, this is how you have to understand. When we go from left to right, you can see that this function, as we move from left to right, this function is also moving up, right? The function is moving up. Meaning of that is the function is increasing there. Similarly, in this third interval where the value of x is from 2 up to infinity, from 2 up to infinity, when x equal to 2, the graph is here. After that, the graph is going up. If the graph is going up, it is increasing. So that means this function, okay, this function, let's call it y equal to f of x. So y equal to f of x, or we can say f of x is increasing on, f of x is increasing on this first interval from -infinity up to -2, -infinity up to -2, and also from here from 2 up to infinity, because in this interval the graph is going up, and also from 2 up to infinity graph is increasing there. Okay, but if you look at the other interval, if you look at the other interval, that is the interval here between these two values, that is from -2 up to 2. Everybody look at the screen now. Between -2 up to 2, you can see that if you look at the graph, when you try to go from left to right, at -2 graph is here. After that, the graph is going down. Going down means decreasing. So the graph is decreasing from -2 up to 2. So we say f of x is decreasing. You can write this now. F of x is decreasing on the interval from -2 up to +2. So the basic idea is when the graph of the function is given, you look at the graph, okay? You look at the graph, and when you go from left to right, if the graph is going up, it is increasing. If the graph is going down, it is decreasing. It is just that simple, okay? Look at the graph and find out where the graph is going up. If the graph is going up, it is increasing. And if the graph is going down, it is decreasing. If you have question, you can unmute yourself and ask, or you can write the question in the chat so that I can answer. If not, finish up your writing and we'll go to the example. Okay, look like you are done copying it. Please copy this question now. This is the question based on increasing and decreasing intervals, or the intervals on which the function is increasing and decreasing. So write that question, sketch the graph also, so that we can answer it. So I'm going to give you about a minute to finish up that writing or copying that question. Diksha, are we done copying it? Diksha? Okay. Okay, we are done copying it. So let's talk about this. From the graph of the function pt, this is the graph of the function pt, because along the x-axis you have the t value, and along the vertical axis you have a p. That means this is the graph of pt. If we have y along the y-axis and x along the x-axis, we say f of x. What we have to do is we have to determine the interval on which the function is increasing and the interval on which the function is decreasing. So everybody look at the board. If you look at this graph, when we start here, this graph goes all the way on that side. There's the arrow. Also on the other side, we have the arrow. That means the graph will extend up to infinity. But here, if we look at this point and then move along the graph is going down. That means it is decreasing all the way up to here, right? Up to the point where I'm pointing. So if I draw a vertical line there, the line will look like that. So for all values, this is 1. For all values less than 1, the graph is decreasing. Okay. And similarly, now if we go from here towards the right, the graph is going up all the way up to here. It's increasing up to there. That means we can also draw a vertical line there. It is increasing up to there. And again, you can see from here, the graph is going down up to here. That means it is decreasing here. See, it's going down there, decreasing. So you can draw another line. So it is creating so many intervals there. And after that, from here, the graph is going all the way up. Okay. So you can clearly see where it is increasing and where it is decreasing. You can also label those lines. This vertical line is at x equal to -1. So you can write that as, x equal to +1. This second line is x equal to 3. The next line is x equal to 4. So our answer will be f of x is increasing on, that's right, f of x is increasing on. So where it is increasing, you can see it is going up from here up to here. That is on the interval from 1 up to 3. 1 up to 3. And also it is going up here from 4. And there is an arrow on the top. That means from 4 all the way up to infinity. From 4 up to infinity. So it's increasing there. So if you want to find where it is decreasing, let's see, f of x is decreasing on, you can see on the first interval here, the graph is going down, right? It's going down there. That is from -infinity up to 1. -infinity up to 1. Here in this small interval, it's also going down. You can see that is from 3 up to 4. It is also going down. And 3 up to 4. So graph is decreasing on this interval from 3 up to 4, and also decreasing here. That's from -infinity up to 1. It is increasing here. That is from 1 up to 3, and also from here, from 4 all the way to infinity. So what you can do is when you're talking about the increasing or decreasing function at your high school level, all you have to do is you have to look at your graph and tell where it is increasing and where it is decreasing. Okay. In your calculus class later on, if you happen to take calculus, over there, you'll use a different technique to determine whether the function is increasing or decreasing. But here, it is just looking at the graph and telling where it is increasing and where it is decreasing. Does that make sense? Okay, awesome. So this is all for today. As you can see, this is our last slide. Okay, we work on two big concepts today: average rate of change and increasing and decreasing function. So before you go, what you have to do is you have to go to the home page of your course and complete the attendance. That is first thing. Second, last time you have completed the homework up to problem number 9, right? Problem number 9. So this time you'll complete 10, 11, and 12. Okay. Aditi, tell me what are the 3 homework problems?
10, 11, and 12.
That's right, 10, 11, and 12. So technically, we are completing everything up to number 12 from our third exercise. Okay, that is all for today. Thank you, everyone.